Hello, everyone. Thank you for joining us today here. I know we have friends all from all many different countries here. So I'm very excited to host this webinar here. My name is Jing Yu. I'm the managing director at Fortress Power. First of all, I want to make sure that if any of you have a problem with, hearing the presentation, there is actually chat section. You can type in, let us know. And I'm gonna just, first make sure if there's any of you have, okay, good. We got here. It looks like people can hear me, which is good. So brief introduction about myself. I've been in solar for many, many years. I, originally come from China, but I went to Germany for my diploma and master degree and graduated as electric engineer. Also got my, MBA degree there as well. I cannot imagine to work in any other field than renewable energy, especially in a solar. That's my baby. So I joined Fortress about 3 years ago now. I used to be country manager for a solar panel manufacturer, but it's getting more excited for me to be actually involved in energy storage, especially in the lithium technology. I also want to quickly bring my colleague, Mario. He is the sales manager for Latin American market. He joined us recently, and we are very fortunate to have him because he speaks, fluent Spanish as well as Portuguese. Mario, you want to give a quick introduction of yourself?
Hola a todos. Bueno, como Jim dijo, mi nombre es Mario Castillo. Acabé de empezar a trabajar con Fortress Power hace ya un par de semanas y bueno, estoy muy contento de trabajar con esta compañía. Estoy aprendiendo mucho y bueno, voy a atender todo lo que es el área de Latinoamérica, desde México al Caribe hasta Argentina. Entonces, pues estaré con ustedes acompañándolos para cualquier solicitud que tengan. Un poco de mi background, yo vengo de trabajar más o menos 15 años en el área de las telecomunicaciones, el cual es un área muy competida, y acabo de entrar aquí al área de esto que es la energía renovable y bueno, me encanta, me arrepiento de no haber empezado antes, y bueno, tengo un degree en Business Administration, y también hablo portugués, español e inglés, entonces si tienen algún requerimiento que sea en Brasil, estaré feliz de atenderlos. Y bueno, cualquier pregunta que tengan la pueden escribir en español. Nuestro panelista Gerardo Vargas, él va a ser uno de los que va a estar atendiendo también este webinar y él habla español, entonces pues estoy seguro que él les puede, no sé, atender cualquier solicitud o cualquier pregunta que tengan. Bueno, los dejo con Jim. Adelante, Jim. Muchas gracias por su tiempo.
Okay, great. Thank you. Good. So today we're gonna focus on to cover, what really talk about the lithium battery storage. I'm sure you've been reading a lot of news. Now, over 90% of the world newly installed energy storage are paired with a lithium battery, and there's a reason for that. And today we're really gonna focus on that section, compare that with traditional lead acid batteries, as well as we're gonna talk when you install lithium batteries, what are few steps you have to pay attention to, as well as depends on what inverters you use. You might need to set up the parameters. So we're gonna cover those areas. So why energy storage? Let's first start with a market trend. So this is a graphic that I took from Bloomberg News. So you can see the energy storage is growing rapidly. Let's focus on here, US market. US is going to be the second largest market. This is what Fortress is based out of. And then look into the Latin American market. It's also pretty good. If you look here, is in a number 4, and it's growing very steady. And we know there's a need for that because some areas the grid is not very stable and electricity price is high, and you guys have plenty of sun. That's just a perfect place for PV plus storage deployment. Here is a graphic in the United States by segment. So you can see here, for instance, here in the US, which utility is still going to be the dominant, this is pretty much very similar in Central Latin American market or throughout the whole entire American continental. But if you look on the residential and commercial section, you also see a very strong growth as well. And here's a little bit more breakdown by segment for Central Latin American market. Like I mentioned, that the utility is the majority, going to have the majority share of the market. But if you look into the remote power, residential and commercial section, you also see annually 30–40% growth, very steady. So that's very good news for all the people that involved in the renewable energy space. Now, what can energy storage do? I'm sure that a lot of you are very familiar with that, but I want to still have take time to quickly go over that, bring you up to speed with the latest technology. Now, these days, energy storage is designed to be flexible to support all kinds of applications that you need. Let's start from off-grid, right? In the past, mainly used for off-grid when you do not have access to the utility power, and then move to backup power. Unfortunately, we got more hurricanes, storms all over the place. And when the traditional PV systems, when the grid goes off, then your system has to shut off too. By adding a battery on energy storage, then it can keep your PV system up and running during those difficult times. Now, very popular application in we've seen that especially in Central Latin American market, or even here in the US, like Arizona and Hawaii, is self-supply. That means people will put in battery there and store the power from the PV during the day and use them in the evening. And that way you can maximize your PV production, and also instead of buying expensive power from the grid, you can use your PV power for the evening as well. And then also another area so called time of use that I don't think applicable to many areas. We've been seeing here mainly in California, where between 4 to 9 p.m. you have very strong, the electricity price could be very high as 50 or 60 US dollar, and when off-grid is only off-peak is only 15 to 16 cents. So adding a battery that can power your home between 4 to 9 p.m., it can save you a lot of electricity cost. We're also seeing that more and more commercial customers are looking to reduce the demand charge, the kW charge, which I'm gonna have a slide to explain what a kW charge is. So here is just a graphic shows the off-grid applications, which is pretty simple. You have solar panels that produce the power, goes through the hybrid inverter, and the inverter power your loads, and any excessive one goes to the battery, and when you need it, the battery can discharge to power your loads. A lot of time people will also add a generator to it just for the cloudy days. And that's the backup. We've seen more backup kind of applications here, especially in the United States. Again, you have the differences is for the backup you do have grid. You can also take the grid to charge your battery if you want it, or you can also send the power back to grid if there's net metering. Net metering means if there's allow you to feed the power back to the grid. And then the other popular application we've seen is called self-supply, and that's like I mentioned, in a lot of Central Caribbean, Arizona, Hawaii. You do also have access to the grid. However, you do not have a desire to send the power back to the grid. You want to use the grid as a backup option. And main reason is, maybe the utility does not want you to send excess power back to the grid, or it just doesn't make sense. You send power back, they're not going to give you any money for that. And this is the time of use rate I'm talking about. I'm not going to focus on this slides too much because I don't think, that's applicable to many places. And here's the one that I want to take a little bit of time to talk about, because I've been seeing also, or we've been seeing that inquiring from, different places, that the commercial customer, mainly commercial customer, like manufacturers, office, big, office complex, they complain about that the utility charge them very high kW charge. And the kW charge is depends on how much power that you draw instantaneously from the grid. And the utility will take the highest number of the months and charge you money for that. So we are very close to New York City. For example, in New York City, they will charge you $35 per kW. Now, if you as an office building, you may draw 200 or 300 kW at once, just for one time, maybe everybody gets in the office. And imagine you have paid $35 multiplying 200 or 300 kW. And that's almost 50% of electrical bill. So in that cases, you can add a PV plus storage, and then PV plus storage will do is it's integrated, it will talk to your utility, measure your load, and make sure that you can set up a threshold, says, okay, I do not want to have my kW charge over 100 kW, for example, and you set it up, and the PV and storage will do automatically for you. And that's, through a very smart energy management systems. This is a very interesting application. I want to bring this to your attention because there's a lot of business opportunity there. And commercial clients, they are focused on return of investment. So as long as you can come up with a financial analysis, makes sense for them, that's something you're going to get them very interested. Okay, now quickly, briefly talk about who we are. We are a lithium battery manufacturer based in Southampton, Pennsylvania. It's about 35 minutes north of Philadelphia. Again, any of you in the area, New York area or Philadelphia area, you're welcome to stop by and visit us. We have a 30,000 square foot facility where we do R&D, research and development. We have our sales team, logistics team, also engineering team based out of here to serve you. And if you have any questions regarding design or installation, or want to have a quote, again, we are here for you. We also have a public warehouse in California. We're going to open another one in Florida soon. We have about 45 megawatt installs worldwide with different sizes. Smaller could be 5 kilowatt hour, and big one could be in a few hundred kilowatt hour. Now, we're also very proud to be selected as exclusive battery partner supplier for SEPTA, which is a local railway company that manages, the Pennsylvania public transportation. And we are the only supply for them. And also work with some other government projects as well across the country. Our factories are based in Shenzhen, China. If any of you been in China before, this is a Silicon Valley in the east, a lot of smart people. And this is also a hub for power electronics as well as for lithium battery manufacturing. If you look in the global supply chain, I would say that especially for the type of our chemistry that we focus, over 90% of what capacity is based in China. And we do design engineering here in the United States, and we send all, we have partner there to put all together for us. It's very similar like an Apple model, right? Apple product design US, and it's manufactured in China by an OEM partner. The factory's been making actually lithium iron phosphate batteries since 2008, and I want to bring this to your, many of you may heard that lithium is pretty new, but lithium iron phosphate It has been deployed over 10 years and it's proven technology. The lithium ion, which we're going to talk later, that used by Tesla, Panasonic, LG Chem really gained their popularity in the last few years. So there's still time, need to prove and watch, see how that chemistries perform, in the during lifespan. Here are the 3 products that we offer. We also stock them here in the United States. We start with a bigger one, 18.5, and then 10 kilowatt hour and 5 kilowatt hour. So it has, different product range to meet your project needs. We see in the United States, the 18.5 is more popular because again, people here are more spoiled, big house, high consumptions like that, so they need more. In other part of, we see more, like in Central, South America, or even like in Africa, that people prefer the 5 and 10 for residential, but for commercial, they also go with the 18.5. We are going to have a new product, which I'm very, very excited about it. This is the Fortress E-Flex. It is a flexible design to be wall mounted or to be even put in the rack, computer server rack. You can buy on the market, and we're also developing a new one with a bus bar. Everything's integrated in the enclosure. That makes installation much easier for you guys. It also comes with SD card to storage all the data for 10 years time period. And also comes with built-in Wi-Fi. So it now enables you to monitoring the batteries local as well as remotely. It's going to come with a phone app, so it's under development. It's going to be available in June 2020. It's going to be here in May, late May. But by the time, we want to be conservative, it's going to be in June 2020. Here are some basic technical specification of the 4 product line that we offer. They certainly have different capacity amp hour here, the eVolt 360 and go down to the 100 amp hour. They are 48 volts battery. So when you choose hybrid inverters, make sure you choose the one that requests 48 volts DC input. For example, like Schneider, Outback, Magnum, and there's some other brands I know. A lot of them are work on a 48 volts. And it's also safe voltage you can work with. Now, lithium is different than lead acids in the sense there's a battery management systems. So there's a power electronics. So we do set up maximum charge and discharge current in the battery management systems. So when you design it, you want to make sure the inverter you hook up, the load, the consumption load you hook up is within that maximum charge and discharging range. We do have a section, not today, but we do have a section that are very dedicated to talk about how to design lithium batteries, follow all the steps. And we can, certainly when we host that webinar, you are welcome to join us and we will go over more in details. The batteries designed to stack the eVolt, you can go 12 of them for one inverter. And eFlex 5.4 is 15 of them to hook up to one inverter. And then the 10, the 5, 10 you parallel 2 and the 5 you parallel 3. When you parallel them, you increase the capacity and total energy. The voltage is going to be still the same, 48 volts. So our batteries, you can parallel them, but not put in serial to increase the voltage. Then I want to bring to your attention. The eVolt has also LCD monitoring. I'm going to show you in the next slide. The other ones, they don't. But again, eFlex, you're going to have a phone app that you can, through the built-in Wi-Fi to view the state of charge, voltage, and current and temperature, those informations. The first 2 eVolt eFlex come with a CAN RS485. So it allows you to communicate with inverters as well between the batteries. They can communicate, they can talk to each other. The 10 and the 5, they don't. You will use them similar like lead assets, but there are a few steps you have to pay attention to, which I'm going to cover that later. They all come with a breaker here for overcurrent protection. We start with a 5 years warranty. You can extend to 10 years with a very small amount of fee. And in both cases, we guarantee 6,000 cycles. Now, I want to talk about a battery management systems. If you haven't used a lithium before, this might be something new to you. There's actually on any lithium battery, if you buy, you have to make sure they have battery management systems. If they didn't have it, it would be a problem, because then there's no way you can protect the battery cells. So here on the market, there's two types of battery management systems. One's called MOSFET, one's contact-based BMS. So MOSFET is a circuit boards that with a lot of MOSFET integrated on it. It's more simple. It's good for a small application. What it does, over charging, discharging, overheat and temperature protection, overcurrent protection, short circuit, open circuit protection. So all those, make sure all the cells are well protected. On the big units, the units that we allow you to parallel more, we choose contact-based or relay-based battery management systems. It's more robust in sense of it handles more charging, discharging current. And also we build in smartness as well here, so you can communicate, right? Like I mentioned, you can communicate with inverters, you can communicate, between the units. And also all our battery management system can do cell monitoring and balancing, which is very important for the longevity of a battery. We use two types of cells. 5 or 10 use cylindrical. It's smaller, like an AA battery. The advantage is, it's flexible. It makes units more compact. The 18.5, 5.4 will use prismatic. The prismatic, again, for larger application, prismatic's more robust for that. Here's the local monitoring for the eVolt 18.5. Now, you might have clients, they're not very technical savvy. They don't know how to, use the phone app. There's a local monitoring, they'll be able to see it, the voltage, the state of charge, the current in and out of the battery, as well as the power. It does also have a local error message here. For instance, if there's a high voltage, then the circle and HV will turn to be red, give you the warning. That's for convenience. Okay, now let's talk about a different battery technology here. This is a section I really want to focus on. Now, you may heard many different battery chemistry, and people get confused by lithium iron phosphate and lithium ion. So what are they? Widely commercialized, there are actually 3 lithium chemistry. The one that we focus on is called a lithium ferro or lithium iron phosphate. Sometimes people also call it LFP or LiFePO. So remember, this is all talk about the same chemistry. So please do not get confused. It's the same chemistry. Then we have a company like, mainly they're focused on automotive, right? Like Tesla, LG, Panasonic. They offer lithium ion. Be more precise, it's lithium, nickel, magnesium, cobalt chemistry. It's called NMC. And then we have also other chemistry. It's called lithium polymer, or name it LiPo chemistry. Now, why we choose the lithium iron phosphate or short-term LFP chemistry here is it's safe. It does not have cobalt element, so it's very safe, and it can be fully recycled, which is also very critical. Remember, we are in renewable energy space, so we want to make the earth better. And it has also very good thermal stability. If you follow news, you probably heard about, like a Tesla car, if that gets an accident, that has a very high likelihood you can catch fire. And I know that few last months that Porsche come with their new electrical vehicle, got 300 units delivered in the United States, and there was one of the unit catches fire while just sitting in the garage, and happened like that. So there's still a way to go for the lithium ion chemistry to be, stable and safe for the people. And I'm sure a lot of companies are working on that, but so far there's still a potential risk for that. And another important feature is that the LFP delivers substantially more cycles. So we guarantee 6,000 cycles. That's twice as many than the lithium ion chemistry. And people can argue with me, but again, we have smart people in the factory and do tests, and the lithium ion chemistry is no way you can go above 3,000 cycles at this point. Also, because you use, stable, all those chemical elements, the degradation rates are slower, means that lasts longer. That's why it gives you more cycles. Now, in terms of the energy density, like, how many watt hour per kilogram, then the LFP is less than NMC and LiFePO. That's why, like, NMCs become very popular in automotive, because they have to pack as many kilowatt hour as possible in the same space. Because all the car manufacturers sell their car at mileage, right? The more mileage they can achieve, they can ask you for more money, but it comes with a cost. That is the safety and less cycles. That's why we've been seeing now consumers, as well as, solar experts like you, being trained that lithium iron phosphate is a much better option for renewable energy applications. There's a video. You can go to YouTube, just type in LFP versus NMC nail test video, and you'll be surprised how quickly the nickel manganese cobalt batteries catches fire once the nail penetrates through, creates a short circuit, and cause a lot of heat. Temperature goes up and the cell catches fire. That's instantaneously. With LFP cell, through the whole test for 4 minutes, nothing happened besides some smoke. This is a graphic that I put it here. I want to show you the differences. The charging stage from LFP is very different than the traditional lead acids. The lead acids battery is more linear, going up. With the LFP chemistry, there's actually 3 stage. There's qualification, pre-charge stage, and then it goes to the buck stage with a constant current. So the current will remains very constant to charge the battery, and to reach to the to the constant voltage, 54.4 in this cases. Then you can see actually the current is going to jump up very quickly, and going to the absorption phase, and different than absorption phase for the lead acids, taking a few hours. With the lithium is pretty quick, it's like 6 minutes, and also there's no float, not required. I know some charge controller it's built with a float. You can float, but float stage is not really applicable for lithium iron phosphate batteries. And then this is how LFP batteries discharge curve look like. Now, if you look into it, first you can see in the beginning, and at the end, the curve is very deep. So that means the voltage, can jump very quickly at low stage. primary, the first 10% and last 10%. In the middle, it's very flat. That also give a little bit hard time for the battery management system or from the inverter to estimate the state of charge of the battery, because there is tolerance plus minus 10%. So in a sense, if you see two batteries sitting next to each other and they're all the same voltage, but state of charge is a little bit different, don't be surprised. Again, this is because the curve is very flat. It is really hard to measure exactly. And then also, now, when we talk about a battery, there's three things have a big impact on the battery lifespan. The first is charging, discharging rate. So the slower you charge or discharge the battery, then the battery will last longer. Just like here, if you look, the 0.2 C is the top one. You slowly discharge, you can see the capacity or more, you get more capacity. If you do 2C, very fast discharge, the capacity will drop. Here, it's much less. It's like your phone, cell phone, right? So you want to charge it, slow. There is a fast charge you can use for your cell phone, but then it's going to shorten your battery lifespan. And the other thing is temperature, which is very good news for if you live in a warm area. It generally is a good news, it's great to live in a warm area. But for the LFP chemistry, here's even another plus. Look here, 25 is the room temperature. This is the reference here. Now, if you have the batteries operating at high temperature range, the capacity is very close. There's no big different changes. That means you will get the much energy out of the battery. But if you operate in a low temperature range, like here where we are in Pennsylvania, or even further in Boston, or even further north, if you had the battery sit outside without in a heated room, then you're going to short the battery lifespans significantly. Okay, so that is important, to know for you. And the third is the double discharge. I'm sure very familiar with the lead acids battery. Every time if you draw the battery more than 50% with the lead acids, then the life cycles can short very quickly. That's why a lot of people design lead acids batteries with discharging rate even like 30%. Now lithium is much better. First of all, lithium, you can fully discharge the battery. You can do it. Of course, it also comes at a cost. You're going to reduce the cycles. Now, for instance, this is the red line here. If you every time that your phone die and then charge back again, that's not good. That's why on the phone they set up 20%. Give you a warning, tell you to charge your phone. That's protect your batteries. If you do at 80%, you could go over substantially more, above 6,000 cycles. And some clients may be conservative and they set up, okay, I don't want to have my battery discharge more than 50%, then you have more than 10,000 cycles. Now you may ask, what is double discharge? Is basically how much you let the battery, draw, right? Like 80%, for example, you let the battery go down to the 20% and then you charge it back to 100%, and that's called one cycle. Okay, I did raise these questions earlier. Why over 90% global energy storage installed are lithium? And here is also economic reason for that. Okay, now we are in the renewable energy space, so efficiency is always very important, and that's what many experts are putting a lot of time to increase the module efficiency, inverter efficiency, as well as the battery efficiency. With the LFP chemistry that we offer, you have a 98% round trip efficiency. Means when you take 10 kilowatt hour to charge the battery, you get 9.8 out of it. The other chemistry, lithium chemistry, has a little bit more, has 3% more loss, and flooded AGM or nickel iron are substantially less. Now, that means if you want to have the same amount of usable power, you need to increase your PV, your photovoltaic size, and that's money, right? That's more money you have to put there. Let's also take a look at the cycles at 80% double discharge. This is, we took different batteries on the market, we started them, and this is the number that we come up. Fortress 6,000 cycles. The other chemistry, lithium chemistry, are less. Flooded AGM, if you do every time 80%, again, it's only 300 to 500 cycles. The nickel iron is awesome. It does deliver 8,000 cycles. Off-grid years, it means if you do 1 cycle per day, how long the battery gonna last you. So with us, you can achieve, 15, 16 years. And the flooded AGM is only 1 to 2 years if you do 80% depth of discharge. Nickel iron is very good. You can last almost 22 years. But again, it's very expensive, and it also needs a lot of space. That's why you hardly see a deployment in the facilities. Usually the utility company, they will buy them and install in the large systems. Now, energy throughput, that's an important topic here. What is an energy throughput? Is the total amount of energy that a battery can be expected to store and deliver over its lifetimes. And how does that number come from? This is, you use the nominal capacity. In this case, we use the 10 kilowatt hours example and multiply double discharge. Again, you only let it, discharge 80%. That means you only get 80% out of that. And then you have also considered the efficiency loss, right? So you multiply 98% plus the cycle life that will guarantee 6,000 cycles. Again, you can even do more, but 6,000 cycles, that's what we guarantee. So if you use that number together, you're going to come up with a 47 megawatt hour energy throughput with LFP chemistry, what we offer for on the 10 kilowatt hour. And look, flood and AGM, they are substantially less. And nickel iron is, on the number 2 here. And this is, this is only a reference number again. This is only, in the United States, and outside the US, the price may be different. Remember, some countries has tariff and fees and transportation cost. So that number could be different. And this is, what our distributors or installers, price to a homeowner here in the United States. So use this number and divide it, the energy throughput, you get 14 cents per kilowatt hour. And look others, 2 times more. Flooded AGM, 3 or 4 times more. Nickel iron is pretty good, it's 19 cents. Close to the same cost that we deliver. And then on top of that is, in terms of safety, the LFP chemistry and the nickel ions are safe. The other ones, either there has a volatile chemistry or can have a release harmful gas with the AGM and the lead acids. In terms of maintenance, the flooded AGM, lead acids and nickel iron, that requires you go back, maintain the batteries every 6 months. And I know that is also a problem for a lot of customers because they can't remember to do that. And that's also going to short the battery lifespan. Another thing I want to bring to your attention is also this graphic here. Now, I was very fortunate to travel in different countries, and especially in Central Latin America market. And one time I was in Jamaica, and our local distribution partner actually also invited a few homeowners to come to the training section. And there was one homeowner that mentioned that he transitioned to the lithium, our lithium battery, and he's very happy because now he can use here air conditioning. In the past, with the lead acids, when he turned on his air conditioning on, like 30 minutes later, the batteries died. And the reason is because with the AGM or lead acids or gel, they're all lead acids family group. When you draw large power out of battery, the battery capacity drops very quickly. And then, of course, the battery wouldn't last as long as it's supposed to. With the lithium, as long as you operate within the battery management specification, you can expect the battery is going to last, as last it's supposed to. Now, we also know with the lead acids, if you buy a 200 amp hour battery, the useful capacity is, they have, so it's 100 amp hour. So the actual capacity is only half of the nameplate. With the lithium, if it's 200 amp hour, you can really get 200 amp hour. Here is a project that a customer shared a picture with us. They changed it from AGM to the eVolt, and the AGM was 250 amp hour with a 6 kilowatt hour usable power, and this is eVolt. You get 18.5 usable power out of it if he wants to, and it's much smaller footprint and very easy to install. Just one single unit hook up to the inverter. A quick summary, the LFP chemistry's advantage: safe, it gives you high energy throughput, it lasts very long, you've maintained well 15, 16 years, and because the long cycles, it gives you very low energy cost. And that's the message that you have to give to your customers, why you offer lithium over AGM or lead acid batteries. Okay, now we're going to talk about what inverters that we work with. We work with many different inverters. Here's a list of the inverters that we tested here: Schneider, Albach, Magnum, SMA, SolarArc, Victra, Morningstar, Midnight Solar. I know they are very popular in other markets as well. And if you have inverters that are not on this list, don't worry, just send us an email, and our engineers can verify that, okay, if that's compatible. Now, here's example. I want to bring the Schneider. We have a very good partnership with the Schneider equipment, with Schneider. We do a lot of training jointly, and it's certainly a very popular hybrid inverter on the market. A lot of you know them very well, so you can stack flexible and single phase or 3-phase. It covers pretty much all application you need. Has very good performance in hot weather, which is a plus if you live in a warm, in a Caribbean area. And you can also hook up a generator with that. This is system installed in Puerto Rico. Here's some basic information. They come with 5.5, 6.8, and they also can, surge very nicely. On a storage capacity, you can go with a 5, 10, 18.5, and you can go 222 per inverter. Now, let's go quickly. Here it's really, I'm just going to focus on a few key steps that you need to pay attention to. We do have also a detailed installation manual that you can follow through when you install our batteries. But in general, when you install lithium batteries, I want to point out, because I want to make sure you know it, and then you're not going to damage batteries because they are still expensive, right? Now here is, it may vary in different other places, but here in the States, there depends on the size of the systems. You need to choose different wire size, and there's a table for that. We use M8 battery terminal, so you just do a M8 terminal ring, hook up to your cables. It has knockout on the batteries. That means the wires, the terminals all covered. It's not exposed to the air, so it's for safety and also for nice installation. It's nice, Now, When you install one battery, it's easy, but when you install multiple batteries, now there's 3 steps you have to pay attention here. One, check the battery voltage, make sure they are within the 0.5 volts differences, okay? If not, for instance, if one is 52 volts and the other battery is 54 volts, what's going to happen is the battery at 54 volts going to start to charge the battery at 52 volts. And remember, the battery is designed to have the lowest resistance as possible. The resistance so low, it can cause very high current, and that could damage the battery. You know, sometimes can be high as a few hundred amp hour, not amp hour, sorry, a few hundred ampere, and that's very high and could damage the battery terminal and the battery management systems. Okay, so that's important, very important. You know, if you don't know, you think that's safe, and you start doing that, and it's going to cause a problem. Second is, when you pair multiple batteries, we always recommend you actually use a terminal bus bar, a plus, a minus, and you hook all the plus, you know, all the positive to the plus terminal, and all the negative to the negative bus bar. And that's because, and also use the same length of the cables. That way you make sure all the batteries, right, they are you know, at the same resistance. That means all the cables are the same resistance at the same operating condition, and that's good for the battery lifespan. Okay, we do not suggest you do daisy chain like in the lead acid battery. If you go back here, just quickly show you here, sorry, you know, like a daisy chain. It's not recommended for lithium, again, because lithium battery is supposed to last for 10-15 years. If you do that way, the battery on the front and on the back are going to have a lot of stress on that. In the middle, they're going to be equal, but the front and back is going to have stress. That's why we recommend this kind of wiring. Now, there's a few, you know, terminal bus bar, and they're not really expensive. You know, the smaller system, you can buy them, or you even can make your own ones. Make sure you use the M8, you know, stop it. That way it works with M8 battery terminal ring. Choose 48 volts and make sure I can handle the maximum charging discharging amperage if you know, for all the battery you're going to put together. Now with the E-volt, you're going to go through the same steps when you parallel them, but there's one thing is which is, you know, big plus when you do big systems is it come with each battery come with RG45 cable, and you will daisy chain them. Okay, so you start with a, you know, IS45. There's 2 ports on the E-volt. One's called CAN, one's called IS45. You start with IS45, connect to the CAN, and daisy chain them. By doing so, then you create a master and a slave relations. So the mass units, you know, going to monitor the slave units and make sure they're equally charged and discharged, so balance them. And that's a very, you know, it's good for large systems for liability performance. Parameter settings here. Now we have on our website, you can download the different parameter setting that we have for different inverters, like Schneider, Auerbach, SMA, and some other types. We are also Schneider and Auerbach recommended battery manufacturer, because both companies also have you know, on that literature, the list fortress power there. And this is the basic parameters here. Usually it's not required equalization, so typically you can turn it off. And you know, you put recharge bulk absorption voltage there, high cutoff voltage, current, depends how many battery you use. You can configure that and put into the charge controller. But again, we are working with a few manufacturers to establish communication. It's in working progress, such as like Schneider, SMA, and then SOARC inverter. Once that communication established, then a lot of parameters you don't have the manual entered. It's already saved there, but it may take a few times, sometimes for us to complete that process. But we are working with those manufacturers that allow inverter to communicate with them, allow the battery to communicate with inverters. Now, there's one thing I want to point out, because we've been seeing a lot of customers that they go through our design guidance, the integration guidance, they set up everything correct, but there's one thing that sometimes they may not think about it, and that is when you set up the maximum charging and discharging rate, especially if you have multiple equipments together. For instance, here you have two Schneider MPPT 60-150, and you have one XW6848, and you have two of the LFP5 that we offer. Now, typically, remember the batteries, each of them handle 80 amps per battery. So total together, the battery can handle 160 amps. 160 amps. So you can charge the battery. Now, when you set up the charge controller and inverter, in this cases, let's assume you want to have the charge controller to charge the battery as well as the inverter to charge the battery if there's not enough sun. In this cases, you will set up a charge controller, 60 amps of each, so that way the charge controller can take the full capacity to charge the battery. And the inverter side, you need to be careful because you have to set up the maximum charging rate. Now, how does this 40 amps come from? Is you use 160 amps maximum, divided 120 amps, because each charge controller, you allow them to go 60 amps. So two of them going to be 120 amps, and you have 40 amps left. And then the 40 amps, divided by, I believe it's 180 amps maximum you can do, you are at 28% rates. So you use the 50 amps divided whatever the XW plus 6848, can charge the battery at the full capacity. That percentage you need to put in the inverter. So that way you're not gonna happen is if the battery gets very low, the PV are charging the battery and the inverters are charging the battery at the same times, and then it's gonna be, too much for the battery and can, fry the battery management systems or even damage the battery management systems. So I want to bring that to your attention. The last section, I'm going to go very quickly because I know a lot of you are been doing PV plus storage for many, many years. This is actually a tool that we designed more here for the clients in the United States, the installers we have here. We have an Excel-based tool that allow you to select what you want to be backed up, for your backup load panel, such as like lights, refrigerators, and water pump, sump pump, kitchen outlet, outlet to charge your phone and watching TV. So those things, critical when you need it, when the power goes off. You select them, and then you, based on that operating hours per day, you get a total consumption. And then this depends, how many days of autonomy or what's the budget of your customer. You can choose the battery bank size and inverter size. Here's an example here. This is a customer. This is the equipment that he selected for his customer, for a homeowner. And then, come up with a basically a total consumption, how much it is. Select different inverters. In different inverters, depends on what inverter is preferred. And then these tools will also be able to tell you what's, if you turn everything on, if it's going to be within the inverter threshold, like running wattage and surge wattage. In this case, it works well. Another thing is that here in the Northeast, as you can see, summer, winter produce completely different amount of energy, produce completely different. So in summer can be twice as many as in the winter. And that's why the client, it's better to break down the PV production by the months. For instance, in June, it's produced, close to 37 kilowatt hour. Now, the half of that can charge the battery and the other half can be used during the day. If you don't use it, those power gonna be, basically be curtailed, right? So you can use to, turn your air conditioning on or do some other activities you want to do. But in the winter, now it's produced much less. So you want to make sure most of them goes to charge the battery. Whatever lefter you can use during the day. So this is not perfect, but this gives an idea for homeowner how to behave in a different time of year. And now, if you have application like I mentioned, time of use, self-supply, or the demand curtailment for commercial customers, feel free to send out project information, and then we can have, our engineering design and come back with you. We have an installer form that we can email you. You can sign up as an authorized installer. We do work with, distributors in different market and countries, and they're the one they're gonna, help you, quote the project for you. They stock the products, for you, and we provide a lot of, product training from here. We also hosting, depends, sometimes we also have our team travel to the different countries and host the on-site trainings jointly with our distribution partners. Here's our contact information. I have also our distribution partner in Dominican Republic, Gennaro Vargas. I want to appreciate that he actually also helped to set up this webinar and send email out and encourage people to join on the. And then here's Mario's contact information and my contact information. So what we're gonna do is here, I'm gonna pull out a question section here. Mario, because I know some is in Spanish, so we'll need to have Mario to help to translate. And the ones in English, I'm gonna answer those English questions. I'm gonna read the question first, answer it. And the Spanish ones, I'm gonna let Mario to, help out.
Okay.
Okay, and also I wanna let you know, we're gonna send you presentation slides as well. And you guys can have it, share with your colleague. Also the video record, we can post this section on the YouTube video, and then you can also share with your coworker. Okay, the first question is from Ruben. Okay, Ruben, looks like you have a hard time to hear us. I hope other ones do not have that issue, because the other ones, I think, looks like you guys able to hear. And then I have a question from, I'm gonna go finish up the English one and Mario and let you go the Spanish one. It's from Mauricio. What do you refer? Am I pronounced that right, Mauricio or?
Mauricio.
Mauricio. Okay, sorry. I need to practice my Spanish. So questions, what do you refer with as safety? And what's the advantage of the safety of the batteries? Well, safety is important, right? I mean, it just give you a safety, like I mentioned about, lithium ion or nickel manganese cobalt. It has cobalt, and cobalt is very temperature volatile. So if there's a short circuit or the cell gets damaged, it will heat very quickly and it will catch fire. And this is very tough, very tough. I don't know if you read the news on, there was a car got accident and catch fire. They sent 30 firemen trying to, save the guy and trying to, basically put the fire out. So safety is certainly very, very important. And I have also a question from Winfredo. Can we use this battery to recharge electrical car? You certainly can. Yeah, common way of doing that is you have energy storage. You have battery hookup, and then you use the AC outlet, right? Car, they all have AC outlet. You can charge it. We actually have also DIY customers that put a LFP batteries in the car and use as a battery, you know, and he been doing that for 10 years. It's a gentleman that based in the north of California, lived off grid for many, many years, and he has an LFP battery for his car for over 10 years. You can also do that. And also from Winfriedo, the other question is, this battery can be recycled. Where is the place to bring it in? Yes, it can be recycled. Now, we've been searching the market here in the United States. We cannot find any institution to recycle it. But in Europe and in China, there's place you can recycle it. And I'm sure now with more battery to be deployed, there will be very soon organization that can recycle the batteries. Good. And I from another question from Mauricio here. Would you refer with, okay, I think I answered this question. Was safety is important, like I mentioned. What if you put a battery in somebody's home and then it has a potential risk of catch fire, and that happens, and a lot of time those homes are expensive homes. Here in the United States, if you put a battery in some $1 million house, and if that has a problem, you as a contractor, you know, you also have a, you're going to be hooked up with that too. Not just the manufacturer, the contract will be also brought to the court, goes through all the paying process. I have a question from Juan. I have a question. As you said, the float charging is not needed in this kind of batteries. Yes, float is not needed. If you can turn the charge controller off, you can turn it off. However, some charge controller does not allow you to turn off, so you have to have float, which is not, it's okay if you let the battery float. But if you can turn it off, please turn it off. And then I have a question from Edgar. Hey, my question is, this one, Mario, I don't know if can you see this one? Because this is has some Spanish words there.
I cannot see the question. Where do I see it?
Okay, you go to the, let's say you go to the question. There's a question above the chart. Let me see if you can see it. If not, you know, if you have difficulty to see it, what we can do is, if anybody writes in Spanish, we will get a report of all the questions, and Mario can, you know, either call you or email you to answer those questions as well.
Give me 1 second.
Yeah. So I just want to make sure, you know, you guys, any question you have will get answered. If not now, but then later on. I have a question from Dioni. I hope I pronounced that right. If not, please forgive me. Is asking, how could I be a certified installer? We can send you a certified installer form. You fill out and with some basic information. We want to make sure that you have already, you know, experience of installing PV systems, and then you can participate in this. You know, you had a product training already, but we have also a detailed design installation training. You can participate, and after that, you're good to go. Yeah. From Rubin again, like I see Equielectric is your representative in Dominican Republic. Yes, yes, we do work with Equielectric in Dominican Republic. So, you know, they carry out products and they bring the product there. And yeah. From one here, only for confirmation, all of the batteries have to have the same charge. If not, the charging process is going to stop. No, that's not you can have the battery that are different, you know, voltage when you hook them in parallel. But again, if the difference is bigger than 0.5 volts, the problem is the battery with a higher voltage also going to charge the battery with a low voltage. So you have the inverter charging both battery, but then you have also the battery with high voltage charge the battery with a low voltage. And that battery with a low voltage is going to be suffer a lot. And that's going to cause, you know, BMS to fry or even shut off or even be damaged. And I have a question from Edgar. if I work with a microinverter, can I use AC couple? It has AC input, it has AC output. Yes, if you use a microinverter, you will, you know, like the inverter I mentioned on the list, like a Schneider, Outback, Magnum, or Sorg, they all can do AC couple as well. So you can do DC couple and AC couple, like Schneider, if you do DC couple, you get a charge controller. If you do AC couple, you just, you know, don't need a charge controller, you can AC couple. And the battery will be hooked to the inverter as well. And Gennaro Vargas, you know, from Equielectric also put here message for all of you, you know, if any of you in Dominican Republic and the Caribbean wants to get a quote of the battery, feel free to reach out to him. Again, his contact information is here, and they are very knowledgeable. They've been in this business for many, many years. They also know as a master distributor for Fornews, which is a German-based inverter company. So they know inverter battery very well. Edgar questions, AP system or N-phase? Correct, yes, you can work with AP system N-phase. However, with AP system, pay attention because AP systems, you have to see which generation. They have, the older generation does not support frequency shift. I don't know if you're familiar with this term, frequency shift. So basically, is, you know, it's a new regulation. In order for the PV inverter to work with a hybrid inverter and AC coupled systems, they work through a frequency shift. So in the case, if the, you know, frequency usually here in the United States is 60 hertz, and if it goes high, for instance, you know, battery is fully charged and you don't have much load needs now, and your PV produce a lot, then the frequency is going to go up. On a hybrid inverter, going to go 60 hertz to 60.1, 60.2, and maybe come to 60.5. Then the hybrid inverter is going to send a message to the PV inverter, tell the PV inverter to shut off. So that's the frequency shift, and it requires both inverters, from the PV inverter and the hybrid inverter has that capability to communicate with each other. Okay, I know Edgar, you post QS1 and YC600. I do know AP system very well. I can, you know, email them and confirm with them if that works, and which inverter they have tested, which hybrid inverter they have tested. We can send that recommendation back to you. So I'm just write it off. Okay. Good. I think that's all the question in English that I have, and there is a few in Spanish, which, like I mentioned, we're gonna send you email back. Now, any other questions? Okay, good. Well, I really appreciate your time. I hope this webinar has been helpful to, you know, help you understand the lithium chemistry better, understand, you know, what's the advantage when you use them for your projects. And again, if you have need any help with the design systems, and you need any training, any questions, you know, feel free to email Mario or me. The best way is email Mario, CC me, because Mario, you know, he will be your point of contact. And if any of you want to have a quote, and, you know, you can certainly contact, if you're in a, you know, Dominican Republic and the surrounding islands in the Caribbean, you can contact Gennaro. He will give you a quote. Okay, and good, thank you.
Muchas gracias a todos por atender este webinar, y espero que los vamos a ver atendido cualquier pregunta que tengan. Entonces, si tienen alguna pregunta, por favor, déjenme saber. Lamentablemente el sistema no me deja ver las preguntas que le hacen a Jing, pero sí, por favor, mándenme el correíto y yo les trato de responder lo más pronto posible. Muchas gracias a todos.
Thank you.
Thank you.
Gracias.
Gracias.
Bye-bye.